All right, part two, we're going to start looking at problems. And we'll talk, there's a lot of different types of problems throughout this section just because there's different situations that can occur. Reminders, we're working with non-right triangles, so Pythagorean theorem is not an option, and SOHCAHTOA is not an option. We've got our law of sines that we just showed in the previous video. And Candy, here we look. This is going to be really useful for angle, angle, side, and when we know an angle, a side, and an angle. So let's put some stuff in here. Just label our sides like our everything. A and A are across from each other. B and B. Now these always might not be drawn to scale, which is fine. We can still get away with it when it's not. So just filling all this info in that we were given. Okay, so calculators are in degrees. This is going to be, the calculator is going to kind of take the brunt of the work here. But these ones aren't too, these first two examples are going to go pretty quick. And the reason why is finding that third angle is pretty easy. So whenever we know two of the angles, well, then the third one's going to be really easy because there's 180 degrees in every triangle. So when we know two angles, the first thing we should do is find the easiest thing, and that is the missing angle. So if we add up the two angles that we have and subtract from 180, we get 49 degrees. So we've got one thing, angle A, I'll just leave them there. Angle A is 49 degrees, so now the only thing we have left are two side lengths. We need to find the side length A, and we need to find the side length C. So we haven't used our law of sines yet, but now is going to be the time that we do it. As I said before, I like having the side lengths on top when I'm solving for a side length, and I like having the angle on top when we're solving for an angle measure. So let's just start with A. It's first in the alphabet. What we say here then is, for law of sines to work, you need to know an angle and its opposite side, and you need to know an angle and then a missing side. So like A is opposite A, but we know the measure of angle A, we know the measure of angle B, and we know B. So that's enough information that we can get started, because as I write this out then, I've got A is to the sine of A, which is 49, as, now remember we always want sides across from sides, angles across from angles. So the information that's enough that I have is B is 27.4 is to the sine of its opposite angle, which is 28.7 degrees. So now to solve this simple proportion that we just created, all we're going to do is multiply each side by the sine of 49 degrees. Make sure your calculator's in degrees, and if we take 27.4 divided by sine of 28.7 degrees, and we multiply that result by sine of 49, we would get 43.1 for A. Now I would not cut any decimals off. I would do this first, and then I would multiply without changing any, don't take any decimals out. Just use the answer, full answer, to multiply, so then we get 43.1. And then we're just missing one more side, and it's side C. My other suggestion is I would use this same proportion when we go to C. And the reason why is if we screwed up either of these red answers and we use those in the proportion in the law of sines, then we would get C wrong. But even if you got one of these wrong, well, I guess you could get one right and one wrong, but if you got one or both of those wrong, that's going to affect your answer for finding side length C. So the safest bet is to just use the given information. So all that given is in black, and we were given angle B and side length B. We were also given side length C, or angle C. So as we go through there, then we can find C by taking C is to the sine of 102.3 as, and it's just going to be the same as what we wrote over here. 27.4 is to the sine of 28.7. So the same thing, to get C by itself, we're just going to multiply each side by the sine of 102.3 degrees. And that leaves us with a C of 55.7. Another quick check, and this isn't going to tell us if our answers are right, it's just going to tell us if they seem correct. Largest angle is across from the largest side, so that's true here. Smallest angle is across from the smallest side, that's true. And medium, that's true. So again, it's just a small check. It's not gonna say yes, your numbers are correct, because you could still get away with it if they were wrong, but it's a small thing that you could do to check. All right, this one we've got a pole tilting towards the sun, so little word problem here. Here's our sun, little grass growing. We've got this pole that's tilted towards the sun, and we're told at an 8 degree from vertical. So all that's telling us is if this is vertical, it's tilted 8 degrees. Well, vertical means 90 degrees. So what we've just described is a 98 degree angle. And it's casting a 22-foot shadow, so that sun is hitting the pole. And it creates a shadow that is 22 feet. And the angle of elevation of the sun, now remember, angle of elevation always opens upwards. Angle of elevation. So when we see that, this is the angle that we're saying is 43. And then we want to know how tall is the pole. So using this information, what we know, what we're looking for, what helps us here is, so far, I need to know a side length, and the good news is I know its opposite angle. So what I know for sure, if I want to find the side length, I would say x is to the sine of 43. And now I just need another pair of a side and its opposite angle. And because I know two sides, I can just subtract from 180 to get this top angle. And the reason why I want the top angle is I've got the bottom side length. So our top angle when we subtract from 180 is 35.5. 39 degrees. I couldn't read my own handwriting. So now we have an angle on its opposite side. So as we finish this law of sines, 22 is to the sine of 39 degrees. We would just multiply by the sine of 43 to each side, because that will cancel. And multiplying this out, we get 23.8 feet tall.